Tuesday, the 9th of February. We are going to be doing our third lesson today on equivalent fractions. So let's have a look. Okay, so your warm up for today. Can you please make this a little bit bigger for you? Pause the video here, and can you have a go at working out these Roman numerals, please? Okay, so we can see here that the I is worth 1, the V is 5, and the X is 10. So I'm just going to move on to the next page to show you the answers. Just make these a little bit bigger as well. There we go. And if you'd like to pause here, and you can have a look if you've got the right answer. Okay, so the first one was quite straightforward, wasn't it? You probably remembered that one. So that was just straightforward. V was worth 5, and then the 3 ones, and obviously 5 and 3 ones makes 8. And then this one, you've got your 10, so you've got your X, and then do you remember it's 1 before 10, isn't it? They do in the Roman numeral system. So 1 before 10 is 9, which is set out like that. And then down the bottom here, we've got 2 X's for representing our 20. And then the same as with the 9, really, we've got the 1 before 5, and 1 before 5 is 4. So let's move on to the main part of the lesson. So I want you to have a little look at this fraction wall. Don't worry about drawing out precisely in your book, but you can make a little sketch of it if you like, and try and have a look at what each section of this fraction wall represents. Okay, so what fractions does this diagram show? And then can you see any fractions that are the same as each other, so that are equal to each other, equivalent? Okay, so pause here and have a little look. Okay, and to save time, I've already put the answers on, so you don't have to watch me do it. So this first bar is 1 whole bar, and it's chopped into 2 pieces. So that's why there's a 2 on the bottom for the denominator of the fraction. And then each piece is 1 piece. So that's why it's 1/2 and half there. And then the bottom bar is chopped into 4 equal pieces. So the denominator is 4, and the one on the top is representing each one of those little sections. Now, if we have a look at what we can see here in terms of equivalent fractions, we can see that 2 of those quarters are the same as 1 of those halves. Okay, because we can see they go up. Imagine they were little roads. That one stops at the same point, doesn't it? See the line here? So we can see that that one, that's half there, and then 2 quarters is the same amount. Okay, so hopefully you spotted that. Right, let's have a little look at this one then. So can you do the same thing again? Pause it, have a little look. What fractions does this diagram show? And then, same as before, can you spot any equivalent fractions? Okay, off you go. Okay, and once again, I have put the answers here, so you don't have to watch me write them all out. So same as before, we have the halves, because one bar was separated into 2 equal pieces. So 2 for the denominator, 1 representing each of the pieces. Then 4 equal pieces, which as we talked about on the previous page. And then the last line, the bottom line, is divided into 8 equal pieces. So we've got 8 on the bottom and then 1 on the top, representing each of those. In terms of equivalent fractions, there's lots on here. So we've got the half being the same as 2 quarters again. And also we can see, if we look at this line here, we can also see that half is also the same as 1, 2, 3, 4 eighths. So 4 eighths is the same as half as well. And 4 eighths is also the same as 2 quarters. And then if we look over here, we can look on this line where my arrow is going up and down. Can you see? In fact, if I can even draw a line for you, so you can see it a little bit easier. If we look at this line here, put a line down there, I can see that, oh, moving the wrong thing. Excuse me a minute. There we go. I can see that 1, 2, 3 quarters, so I've got 3 quarters there, is the same as 1, 2, 3, 4, 5, 6 eighths. So I can say that 3/4 is the same as 6 eighths. And here you can see on the other side, 1/4 is the same as 2 eighths as well. Okay, so there's lots and lots of equivalent fractions that we can see on that fraction wall. Moving on. So I'd like to have a look at this one. The question is, which model does not show an equivalent fraction? And then if you can tell me how you know. So I would like to, you might be able to see from the picture. Pause and have a look. Which model does not show an equivalent fraction and how do you know? Okay, so we can see on here that it's gone a bit small, hasn't it? Sorry about that. Try and wriggle it around without messing it up too much. There we go. So we can see that on this fraction, on model A, diagram A, along the top bar there are 12 equal sections. So I put a 12 on the bottom, and there are 2 of them coloured in. So I put a 2 on the top. And then on the bottom bar, there are 6 equal sections and 1 of them coloured in. So I put a 1 on the top for my numerator. Okay, and I can see that those fractions are equal to each other. Okay, I can tell in 2 ways. First of all, I can see that the lines, the colouring in obviously goes up to the same point on each of the bars. So that's an easy way to see it really clearly. And then I can also see by my multiplying way that I was doing yesterday. So I know that 1 times 2 is 2 and 6 times 2 is 12. So both of those numbers have had the same thing done to them. The numerator, 1 times 2 is 2. And then the denominator, 6 times 2 is 12. So they've both been multiplied by 2. And they've come out like that. So I can see that they're correct. Then if we move on to B, there are 6 12s coloured in on the top bar, so 6 of the 12 equal pieces, and 2 of the 4 equal pieces coloured in on the bottom. Again, I can see that these are equal fractions, they're equivalent fractions because they come up to the same place on the bar, each of the bars, the same amount is coloured in. And also if I look at what they're multiplied by, I can check as well. So 2 times 3 is 6, and likewise 4 times 3 is 12. So those are both times by 3, the top and the bottom, the numerator and the denominator both multiplied by 3. So that's okay. And if I just put times 2 up here on the first one. And then moving down to C, I can see on this one, there are 2 of the 12 equal pieces coloured in on the top bar and 2 of the 6 equal pieces coloured in on the bottom. Now, I can see quite clearly here that the bottom bar is not equal to the top bar because there's more of it coloured in. And if you think about it, if these bars of chocolate, they've each got 2 pieces, haven't they? But the person who's got the pieces from the top bar has got much smaller pieces, haven't they? So although they've still got 2, they're much smaller pieces. So if we have a look down here, we can see that the number that we've multiplied by to get from 6 to 12, 6 times 2 is 12, but 2 times nothing is 2. So they haven't been multiplied by that's times 0. So they haven't been multiplied by the same, have they? So 2 times nothing. Oh, hang on, that is it. Beg your pardon, sorry. 2 times 1. See, I told you it still gets tricky, doesn't it, with the zeros and everything. So 2 times 1 is 2. But 6 times 2 is 12. So they've been multiplied by different numbers, so they're not equivalent. And actually, we can see that that 2 6 is actually bigger. So the person who had the 2 6 would have more. If we look down at our steps to success, multiply the numerator and the denominator by the same amount to find an equivalent fraction. And we haven't there, have we? They've been multiplied by different amounts. And it says if the numerator and denominator have been multiplied by differing amounts, they have, then they are not equivalent. Okay, so let's just check the last one though, because we don't want to count our chickens. We can see that 6 12s are coloured in on the top bar and 3 6s on the bottom. So if we have a look at what's happened to them, 6 times 2 is 12. So the bottom has been multiplied by 2, so 6 times 2 is 12, and 3 times 2 is 6. So I can see that they have been multiplied by the same. So therefore they are equivalent or equal as well. So I can pop a little equal sign. That one goes in those. Okay, so I can see that A, B and D are all equal and C is not. So the answer to our question, which model does not show an equivalent fraction, the answer is C. Okay, moving on. Challenge yourself for 3 minutes. How many equivalent fractions can you find? So just like we did on the earlier slides, take you back to this one. When we did this one, write down all the equivalent fractions that you can find using this fraction wall here. Okay, so pause and off you go. Okay, you've said go again, so you've obviously written down loads and loads and loads and loads and loads of equivalent fractions for me. I'm not going to go through all of them because it would take all day. But a really simple thing to do is to just look down the lines, really, see where the lines are in line with each other. So we had all the ones we talked about before. Here are thirds. Look, that's thirds because they're broken into 3 equal pieces. And I can see that that line there of the third, that's 1/3 goes in there. Is the same. What I would have done is written on them, though I can't write on all of them now because it's going to take a really long time. But that's 1/3, wobbly third. And then can you see this line going down here? It's this one goes up to the same distance. So this is 1, 2, 3, 4, 5, 6. These are sixths on this line. So that's a sixth. It's worth 1/6. Ooh, super tricky to draw. And then that's a sixth as well. So I might have written for one of my equivalent fractions, I might have said that 1/3 was equal to 2/6. So I'd have a 2 on the top and 6 on the bottom is equal to 1/3. And then on the next one down, these are 2, 4, 6, 8, 10, 12ths along the bottom. They're cut into 12ths. So I might say that 4/12ths is equivalent to 1/3 as well. So all the fractions you said are equivalent. If you put a ruler down the screen, they should all line up with each other. So you can see those line up. And then here, look, 2/4 is the same as 3/6 and is also the same as 6/12ths. So there's loads and loads and loads you can do of those and make sure they're the same. And if you want to check that they are definitely equal, then you can check that this top and bottom have been multiplied by the same number. That'll be a really good way to tell. So for your hinge question, pause here please and complete the fraction sentence. So we've got 2/6 is equal to, and I want you to think about what it is equal to. And remember, you have to do the same to the top as you do to the bottom. So pause here and have a go, please. Okay, so let's have a look at the answer. The answer is actually 1/3. Don't just skip on and think, woohoo, I'm right. Let me explain to you why you're right. And if you've got something different, then I'll explain to you why this is the correct answer. So if we put 1/3 up here, to get 1 times 2 is 2. And then 3 times 2 is 6. Okay, so those are both multiplied by the same number. Okay, so they're both multiplied by 2 times by 2. So we can see that those must be equivalent fractions. Okay, now if we were to put 1/5 up there, then 1 times 2 would be 2 again, but 5 times 2 would be 10. So that wouldn't work, would it? And the same if we put a half up there, 1 times 2 would be 2, so that's okay. But 2 times 2 would be 4, so that wouldn't work either. And if we put this one up here, 4/8, had to get from 4 to 2, we would do 2 times 2 was 4, and then 6 times 2 is 12, not 8. So it can't be that one either. Okay, so A is the correct answer because they're both multiplied by 2, top and bottom. So we know that, as it says in our steps to success, the numerator and the denominator have been multiplied by the same amount, so we know that that is an equivalent fraction. Okay, so your task for today, here's the silver task. You've got a fraction more, and it's a bit like we were doing in the main session, trying to make sure you've got all of those equivalent fractions that you can find using this diagram. Okay, it's a slightly different diagram to the one we had in the whole session. It hasn't got quite as many bars on it. So see how many you can write down, okay? And then I'll move you on to, so pause here and have a go at that, and then I'll move you on to gold in a second. Okay, moving on to gold. For gold, how many equivalent fractions can you see in this picture? Okay, so see if you can make some equivalent fractions here. So for example, you may say that, oh, I don't know, I don't want to give too many away, but you may say that maybe 6/12 is the same as half. Okay, so 6/12, because there's 6 out of 12, is the same as if I chopped this in half, then 1/2 would be coloured in, okay, and so on and so forth. So if you can have a little look at that, pause, obviously. And then if you're still keen to push yourselves even further, or if you've done that really quickly and you feel you've got a bit more time, then I'll move you on to platinum. So this one says, Laura says, I know that 3/4 is equivalent to 3/8 because the numerators are the same. Is Laura correct, and explain why? Okay, if you think she is correct, prove that she's correct. And if you think that she's not correct, can you give a correction? Can you say what the correct answer could be? Okay, and then when you've done that, you're all done for today, and I will see you tomorrow for our last lesson on equivalent fractions, in fact. Okay, bye-bye.